Hey, how's it going, everyone? Victor here, and for tonight I have something real fun. We'll try to set up a service provider scenario, and so we'll have two different customers, and we'll be providing layer 2 services for this customer up here called ADA IMG Corp. We'll be doing a point-to-point, and for this other customer here with these three different sites will be doing a VPLS or full mesh setup. And so these are the pretty much the steps that we're gonna take. We'll do the core addressing, followed by the IGP, MPLS setup, iBGP, some router reflector there, point-to-point customer, and then we'll take it from there. So before we go any further, I would like to actually go and recommend some readings that I have here. This is a configuration guide for MPLS and route reservation protocol. Not really necessary, but this is an introduction on flexible VLAN matching and EVC infrastructure. So as you can see here, with one physical interface, we can provide different services. So we can have routed services, we can have different VLANs and put it into a VPLS with the different neighbors. You can also match for a specific VLAN and put that in a point-to-point service. We can do local breaching, um, and I think it also goes on, yeah, the VLAN tag rewriting or EVC platform that allows you to manipulate the tags coming in and going out. Um, More on EVCs, a little more. This is a layer 2 services troubleshooting guide, and I was particularly looking at this site here where it's showing you how you recognize the virtual circuit type mismatch between type 4 and type 5, or Ethernet mode versus Ethernet VLAN mode, or port versus VLAN mode. Mm, let's see what else here. This is another troubleshooting guide, and finally, this is the RFC for, I think it's called uh, encapsulation methods for transport for Ethernet over MPLS. Okay, so and this is an interesting part here when it talks about the row mode versus stacked mode, or Type 4, Type 5 for the pseudo wires. So another interesting reading, and I'll be posting all these links right under the video. So in case you wanna study this a little further, um, but let's move on to the actual configuration. And what I'm thinking is, what I'll be doing is go ahead and set up the first core router, and more likely I'll just gonna fast forward um, on that part while I set up the whole thing, just to save some time. But of course, um, I'll be using my notepad here, and let's get rid of that. Oops. Jesus. Okay. Um, alright, so let's get on to it. Router 1, I'm gonna set the host name as we go. Okay, so interface loopback 0. We're gonna use the name, I mean the number of the box for the loopback. So, oops, what am I thinking? 1111/32. No shot. Um, I do router OSPF1. Router ID 1111. We'll be using OSPF as our IGP, and let me go ahead and enable LDP sync and MPLS LDP autoconfig right away, before we forget. And on the loopback, let's go ahead and advertise it right now. Oops, area 0. So move on to the actual link. We're gonna be using 10.0, and then the number of the two routers, so 12.1 being the last octet, the number of the router. Uh, Oops, I'm sorry. We'll be using /24 for the core, and IP OSPF1 area 0, MPLS IP, exit, interface E2, IP address 10.0.16.1.252.5.250, IP OSPF1 area 0, no shot, MPLS IP, and let's go to MPLS LDP router ID. It's gonna be loopback 0, MPLS LDP label, or label LDP. Oops. Oh, I'm sorry. I'm in the wrong MPLS. And I'm looking for LDP label MPL. Nope. Protocol is LDP, but that's not what I'm looking for. MPLS LDP. Label range, and so we'll be using, just in case we need to, when we're looking later at the LFIB and maybe doing some MPLS registrar, it will be handy to have the labels for the specific links, or I should say the routers, being the same number as the box. So we'll use 1000 through 199. Oops. And MPLS IP and MPLS. That's all we need. Um, let's see. Am I missing something else? Clear this and show run. There's the name. There are labels. Protocol LDP. Loopback being advertised. Auto config sync. And that's all we need for now. Alright, so I'll go ahead and copy all this. And I apologize. And paste it in Notepad. Get rid of the unnecessary stuff. Okay, so let's move on to router 2. And here's a 2, 2, 2, 2, 2, 2, 2. Gig 1 is gonna be 12.2. Gig 2 is gonna be 23.2. Router D is of course 2.2.2, and that's it. Boom. Move on to router 3. Gig 1 is gonna be 3.4.3. Gig 2 is gonna be 2.3.3. This is router ID, and that's it. Router 4. And now that I remember, I don't think I'm enabling the interfaces. My bad. Interface kit 1, no shot. Interface kit 2, no shot. Interface kit 1, no shot. Interface kit 2, no shot. Okay, and for now on, let's go ahead and add that to. Okay, we're on router 4, so gig 1 is 34.4. And let me go ahead and squeeze in the no shot. Gig 2 is 45.4. And the no shot down here. Okay, router ID, and that's all we need. Enable config, paste. Good. Move on. Router 5. Enable conft. Router 5, 5, 5. Gig 1 is 56.5. Gig 2 is 45.5. And down here, that's it. Boom. Router 6, the last one. CSR 6. Our labels. Loopback. Gig 1, 56. That's 6. And gig 2 is 16/6. And okay. Alright, so going back to router 1, and let's do a show Mpls LDP neighbors. There we are. And we should be able to ping all the way to, say, router 4's loopback. And unsuccessful. So what's happening? Show IP OSPF neighbors. Router 2's up. Maybe router 6 hasn't. So router 4 do show IP OSPF interface brief. And yes, router loopback 4 is being advertised, but neighbor she just came up. So let's do that again. Okay, maybe it's taking a little longer. That's good. That should be good. Or do show IP OSPF interface brief loop. Show IP OSPF neighbors 2-way, so still loading. Or no, it should be. Yeah, that should be full. So let's give it a couple minutes here. Show IP route. There's the 4. That's good. And there's the adjacency. And that should be working. What about now? Okay. Alright, so we're all set and ready to um ready to start setting up the first customer, because we are not gonna need the iBGP peering, at least not for now, because the customer here is gonna be a point-to-point. So we're gonna statically set the pseudo wire for this and the attachment circuits and everything. So the iBGP Autodiscovery, we're gonna use it to set up the dynamic peers for the bridge domain, or VFI. So let's go ahead and first, just for the sake of it, do a no shot on the attachment circuit interface, and do the same for router 4. Shot. And now let's go ahead and configure that pseudo wire between router 1 and router 4. So we'll do under the attachment circuit interface, or I should say ADA encapsulation .1q ADA. And so we're gonna match our incoming frames with VLAN ADA for this, and we're gonna place them into the or on the slew wire. So we're gonna say X connect, and the IP is gonna be 4.4.4 for the neighbor, and we're gonna say ADA for the slew wire ID, or the VC ID, and gonna be encapsulation and Mpls. We're not gonna here's where you would set up for a backup pseudo wire or change the MTU. Not gonna do any of that right now, so that looks good. And go to router 4. Interface get 3.80a. Sorry, encapsulation .1q ADA. So we're gonna match whatever currency with VLAN ADA. and we're gonna place it into the X-Connect 101 and 88 encapsulation MPLS. Boom. Alright, so there's the pseudo wire coming up, and if you wanna confirm that, you can do show MPLS L2 transport VC and then the number of the virtual circuit, and there it is, and it says it's up, and we do a detail. You're gonna be able to see that this is a where is it? Not don't see it. Okay, right here, Ethernet VLAN 88 up, and the I'm sorry, the visual circuit ID is 88, destination or the peer is 4.4.4.4. It says the signaling protocol is LDP, as we know. And let's see the MTU. You can also see MTU here, and control word it's on. Not really sure why it will be on, but I think it's a default on the regular iOS. So just gonna leave that as it is for now, and move on to, let's see, switch 7. And we'll not be doing any Q and Q, at least for now, and that's due to the this switches right here, the VIOS layer 2 image doesn't support Q and Q. Like it will let you actually put the commands and everything, but it's not gonna work. Um, so let's create VLAN. Oops, VLAN and okay, never mind. VLAN ADA, and yeah, what the hell? Let's name it point to point scorp exit. Do show run bisection VLAN, and do the same for switch 9. Back to switch 7 interface. Oops, 00 switchboard mode switchboard trunk encapsulation dot 1q switchboard mode trunk no shot, and interface E01. On this one we'll do the same. It's gonna be a trunk, because we can't do any Q and Q, so let's just do, and we need traffic to have the VLAN 88 as it comes into the provider edge. So we're gonna do a trunk one more time. Switchboard trunk encapsulation dot 1q switchboard mode trunk no shot exit. Do the same on router 4. I mean switch 9. Oops, interface key 01. Switchboard trunk encapsulation dot 1q. Q switchboard mode trunk no shot exit. Okay, alright, so we should be ready there. And let's double check here. Show, oops, show interface trunk, and we're allowing ADA on both ports, so that's what we need. Do the same here. Still going through the spanning tree on G01. Should take about a minute more. Okay, let's just leave it for now. Okay, there it is. So and then we'll do just test this real quick. Conf interface FA00 no shot exit interface FA00.88 encapsulation that one Q. Oops, 88, and we're gonna do IP address 192.168.88.10.255.255.255 0 no shot exit. Do the same for CR11. Interface FA00 no shot exit interface FA00.88 encapsulation dot 1Q88 IP address 192.168.88.11.205.205.205.0, no shot exit, and that should work. Um, sorry, 88.10 was it? Yes. And sure enough, it's successful. And if we do a trace, of course, it's gonna be on the same subnet. Oops. 10. And I think I should have said no IP domain lookup, but a little too late for that now. Alright, so let me see what else we can see here. We show MAC address, VLAN, ADA. Sure enough, we see VLANs going both ways. So that's pretty much what a point-to-point looks like. Now, when we're if you're working on like Cisco iOS XR, it can be a little more. The configurations gonna differ slightly. Like the pseudo wires, you're not gonna do it, or you're not gonna build it from the actual interface, but from the point-to-point group. So you need to say a group and then the pseudo wire type and the point-to-point customers or multi-point. So, but it's pretty much the same. So now let's go ahead and set up the BGP or iBGP peers, and we'll use. Let's go ahead and use router 6 as the route reflector. So let's go ahead and set that up first on router 6 and conf t. Oops, Jesus, conf t. Oops. Um, and we're gonna do router BGP, and let's use 666 and neighbor 1111 remote AS 666 neighbor 111 update source loopback 0 neighbor 1111 and address family IPv4 neighbor 111 route reflector applying route reflector applying. Okay, and that's all we need. Section BGP. Let's do this a little faster. Two 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 two. Oops, Jesus. Okay. And let's do the same. Yeah, to be honest, I'm not even sure whether we actually need that exclamation mark there, but whatever. So that's for 2. That's for 4. Or that's for 4. 2, 3. So we got 1, 2, 3, 4, and 5. Okay, see if that works. Where am I? Neighbor. Okay, so under here. Boom. Okay, cool. Let's see. Address family. Hmm. Let me just double check on that. That doesn't look right, I think. Show run section BGP. Alright, so there we have all the neighbors. 1, 2, 3, 4, 5. Um, remote AS is 666, so it's internal BGP, and we're activating the address family IPv4. So later we're gonna have to, or you know what? Let's go ahead and do it right now. So for address shit, router SPF, I mean router BGP is 666, and address family BPL or layer 2 VPN BPLS, and activating then as router reflector clients under this address family. It's gonna allow us to actually uh, roll out BGP Autodiscovery. So we'll leverage this to set up the dynamic peers for the full mesh. So neighbor 111 activate, or I should say route reflector. Okay, so it's asking me to activate it first. Name 222 act route. Okay, so I should do it. Now let's go under each. I should have done a session, no session timeout, but okay. Router BGP 666. Excuse me. Neighbor 666, and let's go ahead and okay. Remote AS is 666. Neighbor update source loopback 0, and address family IPv4 mate. Well, although we don't really need this, but address family L2VPN VPLS NA 666 activate. Okay. Alright, so let's do a neighbor 6 capability change. Okay, because of the VPLS family. Do show run pipe section BGP, and take this, take the whole thing, do the same. Console serial, no auto, no session, timeout, no exit, timeout. Jeez. Okay. Okay. All right. So where were we? Um. Oops. Did it take it? Okay. Um. Oops. I I run commands under the same under the route reflector. Let me make sure that I didn't mess anything up. Let's see. Nope. All looks good. Okay. All right. So do show show iBGP neighbors. Can we do a nope? All right, the huge output, no worries. So as you can see, our only neighbors gonna be BGP. I mean router 6, and on router 6 we should have show iBGP neighbors 1, 2, 3, 4, 5. Okay. All right. So let's go ahead and set up the VGP Autodiscovery. And pretty much this is a way to leverage the route distinguishers or route targets and dynamically set up the peers that are gonna make up the bridge domain or the VFI, the virtual forwarding instance for these full mesh customers. So let's do from here. And because we have a route reflector going on here, we don't really need to have a full iBGP mesh. So as you can see, all we're doing is setting up peerings between all the other routers and router 6. So we don't need a full iBGP mesh. Um, let's do. Actually, we only need the VPLS on I mean the Autodiscovery is set up on CSR 1, 4, and 5 because those are going to be our PEs for this customer. Um, so let's go on the router BGP 666 and do or I should say um, layer 2 router ID. Not sure if we already said this. I think we didn't. Layer 2 VFI, and we're gonna call it 1050 VPLS Fire Pro, and it's gonna be auto discovery. All right, so hit question mark, see what we have here, and we're gonna before the other stuff gets enabled, we need to say the VPN ID, and we're gonna say 1050. Keep it simple, do a no shot. Um, so next we're gonna bind a bridge domain to this VFI or to this VPLS setup. So we're gonna keep it simple. Remember, we could use any number for this. This is in no way related to the actual VPN ID, but let's just say 1050 again. Keep things simple, and not gonna move, not gonna play with the MTU or anything. Let's do the route distinguisher, and we're gonna use the ASANN format. ASANN format. So I'm gonna keep it 666 1080, and the route target again is gonna be for both and 666 1080 or 1050 I should say. I'm sorry. Did I say? Okay. Route distinguisher or no route distinguisher 666 1080. Route distinguisher 666 1050. And what else we have here? VPLS ID. To be honest, I'm not really sure whether we're gonna need this or not, but I'll go ahead and do it anyways. 1050, and that should do it. Let's do a do show run by section layer 2 and grab all this. Oops, right here. Okay. do the same, or yeah, we don't even need that here, so let's do it on router 4, exit layer 2, oops, layer 2 router D, and 444, exit and router 5, and exit layer 2 router ID. That's good. Alright, so now BGP Autodiscovery is in place. Let's take a look at the from router 1. Let's do show. Even if we do a bridge domain, it should show us the whatever we have attached to it. So bridge domain and it's 1050. So there it is. We have three neighbors, or actually two neighbors. Three routers make up for this BFI. So let's do a show layer 2 or VPN, I think. BFI and the name, and do we have it here? Yes. Alright, so there it is. Everything shows up, and if we do a detail, or sorry, maybe. Okay, never mind. What's on the bridge domain? 1050. Nope. Okay, no worries. So now we have the BGP Discovery in place. We have the BFI up and working, and the all the customers I mean, all the neighbors are in there. Now let's get some actual attachment circuits to this VFI. Now there will be an easier way. Instead of using EVCs, we could do oops, um, we could do the same we did for the point-to-point customer, doing a sub-interface and matching incoming traffic with one queue, and put it into the VFI and rich domain and forward it that way. But for whatever reason, the CSRs or this image that I'm using, it doesn't allow you to do that. It's not gonna work like regularly or usually you would say from router 4. Let's do normally you would do Xconnect. Well, alright, so interface G3 1050 regular. Normally you do Xconnect encapsulation that one queue 1050 and do Xconnect, and you would say BFI and the BFI 1050, but it's not gonna let you, at least not here. So instead of that, we'll use EVCs or service instances and match traffic incoming from the customer and place it into the bridge domain 1050 and have it forwarded that way to the corresponding destination. So let's go on the router 1 and interface git 3 and do a service instance Ethernet. Yes. Wow. Okay, I'm sorry. 1050. Keep it simple. Ethernet encapsulation with that one key. We're gonna match whatever comes in with this tag. So that one queue 1050, and we're gonna do a no shot and place this into the bridge domain called 1050. And that's all we need for now. Oh, I'm sorry, I apologize. Before that, we're gonna do a rewrite ingress tag pop1 symmetric, and basically what we're saying here is, all right, so send me whatever you got with 1050, and I'll go ahead and pop the tag off, and or at least the first tag in this scenario, and that's the only tag that it's gonna have, and we'll place it into the bridge domain, and on the other end, because of the symmetric tag, we're gonna push whatever tag is on the other attachment circuit. So it's gonna be also 1050, so we're not gonna have an issue with that. Let's see. Alright, so that looks like all we need. Let's go under router 5 and do a interface git 3. And did we say no shot? Yes. Router 5 Key 3 no shot. Service instance 1050 Ethernet encapsulation that one Q 1050 and rewrite ingress tag pop one symmetric and bridge domain 1050. Hey, let's do a no shot. Okay. Router 4 interface key 3 service instance 1050 Ethernet Ether encapsulation 1050 rewrite ingress tag pop one symmetric and bridge domain 1050. Alright, so that looks good. Let's do again do show bridge domain 1050, and to be honest I'm not quite sure whether this is gonna work because of the um, well, because if you look at show run interface key 3 and then remember we also have a sub interface configured there for the point-to-point customer, so I never tried this like at the same time, so I'm not sure whether this is gonna work or not, but I guess we'll see. Okay, so oops, didn't mean to do that. Okay. All right, so let's try and go on the provider switch 7 VLAN 1050 and name it just for the fun of it VPLS Fire Pro and interface get um, well, never mind because they're allowing everything right now, so show interface strong, just give it some time. And now switch A and let's just show run pipe section VLAN. Where is it? Okay. There it is. This one should be ready now. Switch 7. Okay. Switch A. Oops. Oh, this one I do need to 0 or actually, you know what? Interface range key 0 2 and switchboard trunk encapsulation dot one Q switchboard mode trunk exit show VLAN. Oops. Nope. Show interface trunk. Let's give it some time. And this one should be ready. Yes. Or where's the 1050? Do I need to exit here first? Apparently yes. Wow. Show interface trunk. Let's give it some time. And so we're pretty much at the end of this. If this doesn't work, I'll do is I'll remove the sub interfaces, so force this to make it work. Um, but let's see. Okay, so that's good. Now let's go under the different switches. Switch 14, because we need to have traffic. We need to have 1050 tag traffic. So let's do VLAN 1050. Not gonna bother with name. Interface VLAN 1050. IP address 192.168.150.14. No shot. Exit. Um, but we need to do it. This is trunk. Show switchboard trunk encapsulation that one Q switchboard mode trunk. Okay. And on router 12, this one. we'll do a sorry, interface FA00, no shot, exit, interface FA00, 1050, encapsulation, .1q, 1050, IP address, and 192.168.150.12.25.25.25.0, no shot, exit, and get this out of the way. Switch 13, this one right here, enable config. VLAN 1050 exit interface 00 switchboard trunk encapsulation .1q switchboard mode trunk exit. Okay, interface VLAN 1050 IP address 192.168.150.13.255.255.250 no shot exit, and this should be working now. As long as we have everything up. Do show IP interface brief. Okay, and let's give it a try. I always like pinging for whatever reason my own IP first, and then off to the this is 14, so let's try 12. Oops, and that's working. And now let's try 13, and it's working. Perfect. Alright, so when we first looked at the bridge domain over router 1, we were only seeing one MAC address. So let's see, we are seeing at least 3 MAC addresses now. So show bridge domain 1050, and indeed we are. So that's pretty much how VPLS would be set up. And this, remember, this is a actual emulation of a layer 2 service. So we would be running, we would be allowing BPD use if we want. We would be allowing any layer 2 traffic, or I should say any layer 2 protocols. Um, so I guess this is it. Not really sure what else I can show you at the moment, but let me see what I have here. Okay, so we're gonna leave it at this point for now, and I've been trying to work on some stuff with Alcatel, and I got a hold of this image. This is a SROS, and they call it TMOS, but it's not letting me build the ePipe services or point-to-point services. I've been running into issues, mostly because of the encapsulation for the signaling. It's not letting me set up with Mpls. It's like defaulting back to GRE, but that's some other topic for another day. Um, so I hope you've enjoyed, and please, if you have any questions, make sure to leave me a comment or a or whatever you need to ask. And I hope this has been informative for you, and I'd like to thank you for viewing.